Russell Tackett with HydraForce, an electronic sales and application engineer. Today we'll talk about EVDR 0201A basic setup information. This presentation by talking about the different configurable controllers that HydraForce offers. The first is the EVDR 0101A. This has one PWM output and one analog input. It features Deutsch-type connectors, the DT series connectors. We're going to use a program called HF Impulse to configure this controller. I'm going to use HF Impulse to configure the 01 and the 0201A. The 01A has one analog input, voltage, current, resistive, pulse, PWM, out valve control, and an LED encased in the body of it for put in error monitoring. Input voltage or output voltage 9 to 32 volts, control current up to 2 amps, 40 to 4 hertz, and of IP69K, the 12 converter, range minus 40 to plus 85, and a certification. Some part number mating connectors and programming cables are on the right-hand side. The A is an excellent choice for replacing some of the analog controls that are on the market, including the analog controls offered by HydraForce. We use some list price ranges for $140 for the 1A versus a higher dollar range for the analog controls. More secure in this type of controller. There's no pots to adjust. No that can change over time with an aging controller as far as potentiometers getting dirty. The E is showing output intensity of the controller. It can be saved on a PC for easy replacement of the controllers, or a production environment can be used to flash controllers very quickly, as opposed to the analog control that you have to actually set up each control individually. Give up to 2 amps. No need for different part numbers for different current ranges. So easy to stock. On the HydraForce analog controls, we had a DIN-type connector output. The steps are how to change from the DIN-type connector to Deutsch-type connector to interface with this controller. You can harness with industry-standard Deutsch connectors. Change the coils to Deutsch-type connections. Offers coils with both DIN and Deutsch, so it may be just as simple to replace the coils on your valve. And then there's also a conversion harness you can build. Here's some part numbers that are available from HydraForce to build that connection, going from a DIN-type connector to a mating Deutsch-type connector. The front of this demonstration is the 0201A, and this is that product. It looks very similar to the 101A, with the exception that this one has an 8-pin Deutsch on it, where 101A had a 4-pin Deutsch on it. This is a program called HF Impulse to configure it. One input device or J1939 device. So drive these two valves with either J1939 signals or an analog input or a mixture of both. We'll also look at the same type of ranges that the 101 did as far as voltage, current, resistive, pulse, or PWM. Single output valve control. CAN control for J1939 or CAN open, so perfect for distributed control. If you have a system that needs a couple extra outputs or one extra input, this may be the controller for you. Or better, maybe this is the controller that you sit on a valve on a valve block, and then you work to it. So it's more of a distributed control kind of idea. And then once again, just like the 101As, the 101As have an LED for output error monitoring. Design applications are the same as the 101, 936 volts, drive a 2 amp output, IP69K environmental protection, 12-bit analog to digital converter, temperature minus 40 plus 85, and CE certified. The 0201A is an update from the product, the 0201. And this slide talks about some of the features that happen between the 0201 and the 0201A. A different type processor, so a faster architecture type processor. Does have the LEDs in the case that lets you know how hard you're trying to drive that valve. The PWM outputs as opposed to high frequency PWM outputs. There's a function available for this controller. Control points, we'll understand what that means here in a little bit. Ramps in addition to input ramps, and 1939 messaging was improved. Available on the controller is the EVDR 0201A general purpose valve driver, EVDR, the fan drive controller, and GDR, hydraulic generator control, closed version. So we're on that version right now, available soon. 01A and an ETDR 0101A. This is the software package that we're going to use to configure this controller, HF Impulse, to set up and monitor configurable devices, the 1A and the 201A. It's available free of charge through our electronic portal on the website, and I encourage all of you to download this and do some experimenting with it. You communicate with these controllers, the 0201A, through a USB to CAN device, such as a capacitor or a peak system. Slide with some other screens that will be available on HF Impulse. There's a whole lot of time on this because we'll see it in the demonstration here in a couple minutes. The development kit. So there are several items that are needed to initially set up an EVDR, including obviously the controller, a development harness, a USB to CAN adapter, and some guides. So we have a package where all of these are available as one part number, and there are cost savings over purchasing them individually. Additions you may need can be through email support, electronics.support@hydraforce.com. Information as far as just general information at HydraForce.com. There's a electronic control section that would have all the products we offer and just some more tech sheets and just general information. More specific things, startup guides like I just showed you, or the ECUs and the EVDRs and the displays and anything we offer will be available in our electronics portal. So go to our normal website, HydraForce.com, go on Services and Support, Electronics Portal, as require a sign-in. An EVDR demo using the HF Impulse software. And these are kind of some of the things that we will cover. We'll look at the inputs. We'll drive the coils to data forward and reverse motion. We'll discuss output frequency and how to tune a system. This 1939 interfacing and monitoring input values. We'll monitor values for components for tuning. We'll talk about charting, and then discuss using the control to standalone or additional I/O requirements. Finalize this, and we HF Impulse as soon as I show you the startup guide. This is for the EVDR 0201A. It is a preliminary document right now. We're working on the final versions as we speak. So information on the controller can be found in this document. Any of that I discussed today will be reviewed either through this WebEx presentation or come to these startup guides, and these things are documented here also. Okay, so minimize that. The program HF Impulse, which is what we're going to use to interface to our controller. Going to move to this screen. So you're going to see when initial communications happen as far as in the program. You can see them communicate with a lot of different devices up here. We will be able to communicate with the ECUs being worked on now. The EVDR 01A, which will be the subject of another demonstration. The EVDR 0201A, the basic version, is what we're going to cover today. And the new controller we're working on, an EVDR 0506. So it'll show recent files we had and different projects we can do. I'm going to do communicate the controller initially, so I selected up here. The communication window comes up. It tells us we can communicate to the control either through the capacitor leaf light or the pecan system. So I've chosen to use the capacitor today. Baud rate 250K, and then EVDR 0201A address 0. Search controller, and it found the controller at source address 34. I'm going to select that. It's to change the configuration of this controller. So, for instance, let's say you purchased an EVR, a valve driver, and you want to convert it to a fan drive system. You would use this download firmware to download a file to make it a fan drive. Same thing with a generator drive. Or there's a function that we added for you, or just a general update. You would use this to update your controller. Go look at a program that I have been working on. So we talked about here, you can save these ICF files. So it set up on one controller and then download it into another one. So, and we see we've got a tree on the left-hand side. There's information on this as far as project name, ECU model, and firmware version. Settings. You can up to be 0 to 5 volt, 0 to 10 volt, 0 to 20 milliamps, resistance type input. EM120 is a temperature probe that you can wire into it. A digital input, so an on off. PWM input, so if you have a foot pedal that gives a PWM output, you can wire it into this. And then just general frequency. So it says 0 to 5 volts. Most of them that you'll find as far as an electronic joystick are going to operate, or even pressure sensor, are going to operate between 0.5 and 4.5 volts. So I set these tops here, 0.5 to 4.5 volts. Also, if you want to do any ramping on the input, so for instance, vehicle that runs over rough terrain, you may desire to have a joystick that has a little bit of I don't want deadband, a little bit of time conditioning in it, and you do that with these functions here. All schematic is where to wire the input into, so pins 2 and 7. Once this information is located in the startup guide for the 0201A. Settings, I'm going to have an external input drive both coil A and coil B. This is voltage range, 0 to 5 volts, because that's what we said the input would be. And capacity of the controller is 0 to 2 amps. So amperage left and voltage on the bottom. And I'm going to drive one or the other coil depending on the voltage. So a volt, when the joystick's at 0.5 volt, I drive 1200 milliamps as far as the output. On down to signal in at 2.35 volts, signal from at 2.45 volts, I'm sorry, they're driving no current. So joystick that is a spring in the center, the spring to 2.5 volts. So 2.5 volts down to 0, it's really 0.5 volt to 2.45. I'm going to have one coil, and then from 2.75 to 4.75, I'm going to drive the other coil. And that's that as far as, if you want to put different currents in here. Set breakpoints, you could have it down to one breakpoint, so it's just a straight line. The frequency, this is specific to the device you're trying to drive. So for the device I have with the valve and coils, 200 hertz is the recommended frequency. This can be found in the HydraForce catalogs. T9 settings. If we were going to transmit information to the coils, as far as command information, we would set that up here. That's subject of the advanced demonstration, the 1.8 advanced demonstration. But today I want to transmit my analog input value on 61450. And it's just set here. I'm not going to talk about a whole lot. That'll be the subject of the advanced demonstration. What we saw before. And so a program I download to it. So the voltage for the analog input is read at 2.58 volts. So if I choose this around, I can see my input moves, and you can also see different color lines representing both A coil and B coil being driven. Let's go back to the information page, and we can read the firmware version now that we're online. Okay, so you may recall we set up errors, both maximum and minimum of the input error. So I get monitor one analog input reach a volt. I'm going to keep it because that's considered an error condition. Sending back neutral, which is about 2.5 volts, and these will not go away until you cycle power for safety. Okay, I'll turn my power supply back on again and go back online. Okay, looks like a little bit. I'm going to a more of a plus, so you can see I'm driving B coil. Once I get the 4.5 volts on this, I set the same error. Couple of an indicator in the lower right-hand corner, and I get some verbiage or an explanation of what's going on. So it's the error input signal, voltage of normal to high source, the cycle power. Okay, so we've seen that cycle long enough. So turn the power off until you get the connection failed. Come back on again. Okay, log on. So I did voltage, which therefore is allowed me to drive my B coil or drive coil. Okay. Talk about starting. We've got a button in the upper right-hand corner called charting. There's some things around here. Okay. Then charting. Export data. I'm going to export it to this here. Save. Yes. Open up that file. Computer is saying 12:51 p.m. so we can see it gives us a time. It tells what our A coil current is doing, what our B coil current is doing, and what our input signal is doing. Nice little recorder. It's just something to help troubleshoot the system. Oh, charting again. Last thing I want to do, when you're starting up a machine, you may not have your analog input wired in. So there's a way to values as command to the outputs. I'll show you that now. We log and go to scale. The type use, I can set it up for a J1939 message. To the controller. section. We see that as the system is configured right now, I've got one message that is both A and B. In which I can select enable and then give a command to drive the valve. And B valve. We will turn this down a little bit. Go back to scale. We notice that our value has changed from a voltage to a digital signal, 0 to 1023, which is a. So we can see that we are monitoring numbers 0 to 3. This presentation on the EVDR 0201A controller. The last thing I want to say is, there's 2 configurable controllers that are available. The EVDR 0101A, which is 1 PWM output and 1 analog input, no CAN, and also EVDR 0201A, which is 2 PWM input or PWM outputs, 1 analog input, but it has the ability for CAN. Please email us at electronics.support@force.com.